Hello everyone. We'll see today the concept called as a super node analysis with respect to electrical circuit analysis. So what is a super node? Let us see that. So when the circuit is given, so we can easily identify the nodes. How many nodes are there? Based on that, I can say the node and I can determine the node analysis. So what is a super node? So super node is nothing but whenever we have a voltage source, let me take this as a voltage source, okay, connected between two voltage nodes. Let me take as a V1 and V2, and this is, let me take as a 5 volts. Now there is a voltage source between two nodes without connecting any circuit elements. So this voltage source is connected between V1 and V2 node without any circuit elements. And the reason surrounding this, voltage source which connects the two node directly is called super node. Okay, so this is called as a super node. So voltage source connected between two voltage node without any circuit element, and the region surrounding to this voltage source which connects the two nodes directly is called super node. So let us take a simple problem and we'll try to analyze, right, how this super node can be solved. Let's take a circuit. So let me take a 1 ohm resistor, and this is one more 1 ohm resistor, 4 ohm resistor, and I have a current source and a voltage source here, and a 4 ohm resistor here, and this current source is 2 amps and this is 8 volt. So here the nodes are given. So this is V1, this is V2, and this is V3. There is one more node which is called as a ground node or 0 node. So now these are my two nodes right now. So between the two nodes there is a voltage source which is connected without any circuit element. Hence I can say it is a super node. Hence it is said to be as a super node. Okay. So usually in the problem, whenever they have been asked to find any of this parameter in the circuit, they will not mention whether it is a super node or not. We should identify the circuit. If the voltage source is connected between two nodes without any circuit element, it is said to be a super node, right? So we'll try to simplify this. So let us assume the direction of the branch current here. So this is I1 and this is I2. So whenever I am doing a node analysis, the current entering the junction or leaving the junction is very, very important, right? And this is I3 and this is I4, which is given in this problem, and I5 is here. These are the branch currents which are given in the circuit. So let us solve this problem. Applying KCL, whenever the node analysis is given, we make use of a KCL. Whenever a mesh analysis is there, we apply a KVL. So hence it is a node analysis and it's a super node. I am making use of a KCL. KCL at node 3, or I will take node 1. There are 3 nodes at node 1. So at node 1, I can take current entering is equal to current leaving. the current entering is equal to current leaving. At the node 1, so which current is entering? If you observe here, the 2 amps is entering, so it will be 2, and the leaving currents are I1 and I2, so it will be I1 plus I2, right? So let me take this as equation number 1. Similarly, at KCL at node 2, KCL at node 2, so this is my node 2, so current entering equal to leaving. Once again the same concept, current entering, E is entering, L is leaving. So entering here is I2 and I3. I2 and I3 are entering. I2 plus I3, and the leaving current is I4. Let us take this as equation 2. Similarly, KCL at node 3. KCL at node 3. At this point, so current entering equal to leaving. Once again, entering is equal to leaving. Which are the current entering? It is I1 plus I4 is entering, that is equal to I5 is the current leaving. If you observe that the current I5 is leaving, I1 is entering, I4 is entering, I5 is leaving. So let me take this as equation number 3. Since in this circuit, if you observe that the node 2 is a super node, so the node 2 is a super node, so which is given with a voltage polarity, so where the V2 will be of plus 2 volts. Node 2 is a super node. Because other node is 0, I am not considering that, so hence node 2 is a super node, and that is V2 is a super node which is of 8 volts. This is given. So applying the node analysis at node 1, node analysis at node 1. So in the node 1 already we have been taken that the currents are entering here, so I will write the first current. I1 is equal to V by R. If you go back here, look at here, current I1 is here, right? So current I1 can be written as I1 is equal to, so there are 2 voltage nodes, that is V1 minus V3 divided by the resistance, the current flowing is 1 ohms. So I1 will be V1 minus V3 divided by 1. V1 minus V3 divided by 1. Or I can also write as V1 minus V3 is equal to I1. Let me take this as equation number 4. Similarly, for the circuit I can write I2 is equal to, if you go back here in the circuit, so I2 is here, I2 will be V1 minus V2 divided by once again 1. I2 will be V1 minus V2 divided by 1, or I can write as a I2 is equal to V1 minus V2. Let me take this equation number 5. Similarly, the current I4, if you look at the current I4 is here, it is between V3 minus V2 or V2 minus V3, V2 minus V3, V2 minus V3, and the resistance, the current flowing is 4 ohms. I can write as 0.25 V2 minus 0.25 V3 is equal to I4. I will take this as equation number 6. The last current, the I5, I'll go back to the circuit. I5 is here with respect to V3 and 0 node. So it will be V3 by 4. V3 by 4. Let me take this as equation number, or I can simplify this, it will be, so 0.25 V3 is equal to I5. I will take this equation number 7. Now substituting equation 4 and 5 in 1 and substituting 4, 6, 7 in 3. Okay, so that will be 2 minus v1 minus v3 plus v1 minus v2, so that equal to, so 2 equal to 2 into v1, there are 2 v1s minus v2 minus v3. If I simplify further, I will get as a 10 equal to 2 v1 minus v3, because v2 value is 8, which is from the circuit. v2 value is 8 volts. So let me take this as equation number 8. And from equation 3, I have I1 plus I4 is equal to I5. Substituting the values of I1, I4, I5, I1 is V1 minus V3 plus 0.25 V2 minus 0.25 V3 is also equal to 0.25 V3. Once again substituting for V2 is 8 is 8 so if I simplify that, I will get V1 minus 1.5 V3 is equal to minus 2. I will take this as equation number 9. So substituting equation 8 and 9, we get V1 is equal to 8.5 volts and V3 is equal to 7 volts. So therefore I1, after substituting back these equations in the above equations, we will get I1 is equal to 1.5 amps, I2 equal to 0.5 amps and I4 equal to 0.25 amps. Since I3 already we got above there, and I5 will be equal to 1.75 amps. So these are the currents. So this is how we need to solve using the node analysis. That is a super node analysis. Okay. So thank you.